So welcome everyone. Today we're going to talk about SDL, which is a thing that I've been experimenting with on my spare time in the last weeks. It stands for the Simple DirectMedia Layer, and it is a library written in C that provides low-level access to audio, keyboard, mouse, joystick, and graphics hardware via OpenGL and Direct3D. And it is cross-platform, so it runs on Windows, Mac OS X, Linux, iOS, and Android. So it's sort of an adapter layer that lets you access all of these things on all the different platforms without bending backwards and doing weird stuff. It was created by a guy called Sam Lantinga, probably butchering his name, and it was first released in '98. It is zlib licensed, which means that you can use it for pretty much anything. And the current version is at 2.0.3. There are two sort of big versions that people are using, so it's either SDL 1.2 or SDL 2. And this is used in video playback software, emulators, and games by companies like Valve, Rovio, and Crytek. So it's used in a lot of Valve games. I think it's like a central part of Steam. It's used in Angry Birds that Rovio does, and it's used in the Cry engine by Crytek. So, and it's usually used to get access to, like, for example, an OpenGL context. To do that on different platforms means you have to jump through different hoops, but with SDL you can just get one really simply. And yeah, so it wraps OS-specific functions that games and media software frequently use. And it is split up in a bunch of different subsystems that are kind of interesting. So the basics one just initializes the library, allocates some things, links in some dynamic libraries, I guess. Then we have video that does video. So this lets you get access to OpenGL contexts, bring up windows, get a renderer, and they also have a basic 2D API that you can use straight out of the box. And I think that it is using OpenGL and DirectX on the back end to do the actual rendering, because it is from STL2. They have a hardware accelerated 2D rendering API. There are also other things, so input events to get input from the user via joystick and gamepad and keyboard and touch and everything. There's also force feedback, audio, and it abstracts like basic things like threads, because threads behave differently on different systems. But using SDL, you can get like a unified API to threads on all these different platforms, which is great. You can also get timers, which will you can set like a callback that will be run on a different thread in a couple of seconds or whatever. And then they provide file abstractions, which is also great because that works differently in all the platforms. You can also do dynamic linking. You can get information about the platform. You can do power management. So if you are on a laptop or on like a mobile device, you might want to check like, am I on batteries or am I plugged into the wall? How much battery have we got left? Can we do this expensive thing or whatever? And then there are some additional miscellaneous stuff. Like, for example, they provide their own assert macro, which is pretty sweet because assert behaves differently on different platforms. But also their assert includes a bunch of extra features that are really nice to use. So this is my last slide. So now we are going to look at some C code that I wrote. So this is going to be a little demo of SDL and how simple it is to actually get a window up and render something. So in this directory, I have a binary that I'm going to remove. Aside from that, I have an image. Can all you guys see this? I can bump the size, I think. Yes. Like that? Yeah, great. So I have an image file, a C file, and a make file. So if we look at these in Vim, so I have a really simple make flag. All it does is compiles the C file. It gets C flags and libs for STL. So there are some like special compiler flags and some dynamic libraries that you have to link in when you compile it. That's pretty simple if you use pkg config. And so this is the program, and all it's going to do is to launch a window and display an image is the purpose of this program. So we start off with declaring a bunch of variables. We have two ints that are actually booleans, but in C you don't have booleans, so these are integers. And then we have some pointers to STL data structures. So we have a window, a renderer, a surface, a texture, and then we have this thing that represent an input event. So we start off by saying that we are currently having no errors and we're not going to quit. And then we start initializing stuff. So the first thing you have to do when you are using STL is to call STL init. And this function takes an integer which represents which of the subsystems you're going to use. So in this case, we're only going to use the video one. So we just give it that constant. But if we want to use more of them, we can just OR them together like a bit mask. So it's pretty simple. And if that returns something different than 0, then we have an error. And we want to say that and then say we have an error and go clean up. After we have initialized STL, we can actually create our window. And that's pretty simple. It's just one function call. Whereas if you want to create like a window in DirectX, you have to have like 5 or 6 pages of code just to get that working, because you have to get your context and you have to figure out an adapter that fits the resolution you want to use. In STL though, you just say like, I want a window, it should have this title, it should be positioned at, in this case, 100 from the top, so 100x and 100y. And then it should be 640 pixels wide and 480 height. And then you can supply some flags. So we want to show our window directly, so we pass the STL window shown flag.
Were there some other flags?
There, I actually don't know. Maybe you can start it minimized or something. I actually don't know. But if it fails, we report that and exit. After we have our window, we can get access to a rendering or a renderer that we can use to render into this window. And to do this, we called create renderer with a window. -1, I can't remember what that's for, but it needs to be there. Then we pass 2 flags, so we say that we want an accelerated renderer. So this is going to use the hardware accelerated rendering API, and then that we want to use vsync. And vsync is nice because that will sync up our rendering with the frame rate or the update rate of the monitor. So a lot of monitors these days have 60 hertz update rates. So that this will sync up so we only render 60 times per second. Because rendering more than that will actually be wasteful since the display cannot display all of these frames. So we turn on vsync. If we fail, we error. You start seeing a pattern here, I guess. We always have to check if we have errors, and if we do, we can get at the error that happened using the SDL get error, and that will just return a string. So we can just format that into whatever we print. So after we got our window and our renderer, it's time to load our texture. So we want to load this image called hello.bmp, and we can do that with some standard STL functions. So we have STL load bmp, and if you want to load more or other formats. So for example, if you want to load a PNG or a JPEG, that is actually not built in. Instead, you have to use another library called STL image that integrates with STL. It's like a side project to STL. We load something called a surface, and a surface is a structure representing this image that is stored in RAM. But to do accelerated rendering, we actually don't want to store stuff in RAM because then we have to use our CPU to get at that. So instead, we want to store this in the VRAM, or the video RAM, on the graphics card. And when we store something there, it's called a texture. So from this surface, we create a texture, which will actually copy this thing onto the graphics card. And as soon as we're done with that, we can just free the surface and be done with that. If we fail, we report that. So now we have done all the initialization we need to do. So now we can enter our main game loop. So this is a while loop that will run forever or until quit is true. So in here, we start out with clearing the screen. So we tell the renderer to just clear everything. And then we want to copy our texture onto our rendering surface, or our renderer. And we do that using render copy. We pass null here, and these are actually used to say where on the screen or in our window we want to render this. If we pass null, it will be 0, 0. And then the second null is for if we want to clip our texture. So for example, if we have a big texture that is a sprite map for like a player character, though, so it has a lot of frames, we could actually use the second thing to cut out just the frame we want from that texture. And all this is done in the GPU, so it's very fast. And then we present our renderer. And when we call SDL render present, this is where the vsync happens. So if I actually don't know the implementation details of this, but if we, I'm expecting that if we are not, like if the screen is currently rendering something, it will block until the screen is ready to render again, and then it will render it. So that does our rendering. But if we didn't have this while loop here, it would just render one frame and then quit instantly, and that's not what we want. So that's why we have this outer while loop. So after we have rendered a frame, we use the STL poll event to check if we got any input from the user. And we pass a pointer to the event we allocated before. So it will populate this event if there were any events. And we use a while loop here because multiple events could have happened during our rendering. So we have to loop over all of them and look at them. So when we look at them inside the loop, we switch on their type. And in SDL, there's a special SDL quit type that will represent however you quit a program on the current platform. So on my system, it's using X11 to show the window, and I just send it an X11 kill signal or close signal or whatever it's called, and then it will just do the right thing. On Mac OS, it will close when you do Command Q. Other platforms I actually don't know, but it will do the right thing. So that's pretty sweet. So in here we set quit to 1. We break out of this loop, and when we loop around up here, we will now fall out of the loop and continue down here to our cleanup. And here we just destroy our texture, destroy renderer and window, and then we quit SDL, which you have to do, and then we return whatever is in our error. And if there are no errors, error will be 0, and that will be a success. So now that we've seen this, let's try compiling this. So in this case, I can just type make, and that will run our compiler and create the hello binary. And if I run this, we get this. So this is actually our image being rendered into a window. and when I press in my window manager Shift Super Q, it closes, and then we're done. So that's how that looks. It's a lot less work than if you try to implement this yourself on all the different platforms. You would end up with a bunch of if-def and all that. So SDL is really great for that. So what I'm actually doing in my spare time is I'm building a simple 2D game engine, mainly for fun and for learning. And right now it can render to the screen and do some physics. So the last weeks we've been using Unity a lot here at thoughtbot Stockholm, and so I've tried to sort of model this pretty close to how Unity is structured. So here we have a scene with some objects in it, and these objects can have components that is responsible to do all the rendering and all the calculation, all that stuff. So in this engine, which is called Pixel, we can declare a bunch of data structures here, and then let's jump down here. We instantiate some things and tack on some components on them. So what this will do is it will draw an image of a player. I'm just using weird images now, so it doesn't look good at all. And then it will attach a weapon to the player using let's see, add child. So just as in Unity, game objects can have children, which will render inside. So it will change the coordinate system for the child to be relative to the parent. So this will create a player that has some mass. So it will start falling when the game starts, and the weapon which is drawn on it, which is an image of a centipede for some reason, it will fall with it. So if we try running this, looks like this. So it just falls out of the screen because there are no colliders for it to collide with. Yeah, that's it. Thanks.
Thank you.
Any questions?
I have one question, one comment. In the source code you showed earlier,
Yes.
some of the functions you check the return type, or the return value to see if you've got an error or not.
Yeah.
Do all these other functions also have a return value to indicate if, like, render clear? Does that give you, can you see if that failed also with the return value? Or
So some functions are able to fail. Mm-hmm. So for the initialize or create functions, these will fail, like if it can't allocate memory and all that. So I actually don't know off the top of my head if render clear, render copy, and all these can fail.
Okay.
Um, yeah, but
the other thing that struck me was when I saw that initialization code, it was great to write a macro, so you could make, make each of those things a one-liner instead of a five-liner, sort of.
Right. Yeah. We probably could in this case. Yeah.
So SDL, how can you practically like use it? Is it you use it to build a game engine, or you can use it to build games, or?
Right. So SDL is pretty low level. So it provides like rendering functions and audio playing functions and all that, but it is not an engine. So like, for example, it doesn't have physics or anything like that, and it doesn't really have like a structured way of rendering or having objects or anything like that. So that's why I'm implementing the game engine to provide structure and simplicity of use.
But under the hood it uses OpenGL. Right?
On this platform, it does. On Windows, it uses DirectX.
So this is like a higher level than using OpenGL.
Right, and for SDL, they only have an accelerated 2D API. So if you want to do 3D, you can say like, give me an OpenGL context, and then you can write your OpenGL program. But it's even if you do not use the 2D rendering, it is very helpful because getting an OpenGL context and opening a window on different platforms can be very different and require a lot of code. So it's very helpful. Great, thank you.